Lesson 8-1 Relations and Functions, and in this lesson you learn to use tables and graphs to represent relations and functions. Why is it important? Because when you study motion and physical science, you will evaluate functions. Okay, so let's take a look at this application in ecology. Have you ever thought you could make a difference in landfills by recycling? Think again. The table at the right shows how the United States compares to other nations in terms of the amount of annual household waste. These five countries produce the most waste in the world. So if you take a look at the France, okay, the annual domestic waste in thousands of tons is 15,500, and equivalent in pounds will be per person, but be 634 pounds of waste per person. Okay, Great Britain, 15,816, equivalent per person in pounds in terms of waste, 620. And look at the United States, it dwarfs everybody else, 200,000 tons, okay, of waste, domestic waste a year. And per person, we average around 1,900, okay, pounds of waste every single year. Okay, only Germany comes second. So we have all that waste, okay, and the data that you see up there could be displayed using a set of ordered pairs. Each first coordinate would be the annual domestic waste, and each second coordinate would be the equivalent per person. So what it's saying is that we can make this table right here into ordered pairs. Okay, this would be our x coordinate, and that would be our y coordinate. Okay, and this is what's going to come out: 15,500, 634, 15,816, 620, 40,225, 634, and so on and so forth until 20,780, 741. Okay, so with this data, we can say that these two pieces of information are related to each other, because if we look at 15,500, okay, and 634, we can say that for an annual waste of 15,500 pounds, okay, per country, okay, the individual person's equivalent waste, okay, is 634. So these two numbers are basically related to one another. In the United States, for example, this is the ordered pair. Our annual waste is 200,000 pounds, and the equivalent pounds per person is 1,925. Okay, so I talked about a relationship between the two numbers. So let's talk about a relation. A relation is a set of ordered pairs, like the set above. Okay, and the reason why it's called a relation because they are related to one another. The set of first coordinates is called the domain of the relation, and the second coordinate is called the range of the relation. So the domain of the relation above are your x coordinates, or your domain, or your 15,500, 15,816, all the way to 20,780. And the range is 634, 620, 1,925, and 741. And if you notice, 634 is listed only once, even though, okay, there are two of them right here. Okay, one in France and the other one in Japan. Okay, now you might ask, why are the two numbers different? 634 here, while in Japan it's 40,225. It might also mean that Japan has more industrial waste, which does not involve waste of an individual person. That's probably one of the reasons why the numbers are different. Okay, so a relation, okay, can also be modeled by a table or a graph. For example, the relation -3, 1, 0, -2, 4, -2 can be represented in each of the ways shown at the right. First, we talked about a table, okay? X coordinates and the y coordinates, -3, 0, and 4, -3, 0, and 4, and 1, -2, and 2, 1, -2, and 2, okay? And it can be also graphed. If you graph those ordered pairs, you have negative 3, 1, 0, negative 2 right here, and 4, negative 2. Okay? Before we go to example 1, let's answer this question. What is the domain and range of this relation? Of course, the domain would be your x coordinates, would be negative 3, 0, and 4. And the range would be your y coordinates, 1, negative 2. Okay? And we don't repeat negative 2 because we don't repeat the ranges or the domains. We only say it once. Okay? Let's take a look at example 1, see how this works. Express the relation shown in the graph below as a set of ordered pairs and determine the domain and the range. Okay, so the set of ordered pairs is simply 1, 3, 5, negative 5, negative 4, 0, 2, negative 3, negative 5, and negative 4. Okay, and the domain are all your x coordinates, 1, 5, negative 4, 2, negative 5. And the range is composed of all your y coordinates, 3, negative 5, 0, negative 3, and negative 4. Okay? Now let's talk about a relation being a function. This type of relation, the one in example 1, is called a function. And let's define what a function is. Okay, a function is a relation in which each element of the domain is paired with exactly one element in the range. Okay? So write this down in your notebook and memorize this. A function is a relation in which each element of the domain is paired with exactly one element in the range. Let's take a look at example 2 and see how that definition works. It says here, graph each relation, then determine whether each relation is a function. So if we graph these ordered pairs 6, 0, 3, 8, 6, negative 1, and negative 2, 3, this is what we're going to come up with. Okay? And if we graph this relation right here, this is what we're going to get. Okay? Now, what do you notice about letter A? Okay? So, we have the domain, which is 6. Okay? And the domain 6 has been paired with two ranges, 0 and negative 1. Okay? That means this is not a function, since the element 6 is paired with two elements 0, negative 1 in the range. Okay, in letter B, you notice that each element of the domain is paired with exactly one element in the range. So letter B is considered to be a function. Okay, and we can also determine whether a relation is a function or not by using what we call the vertical line test. So you can use the vertical line test to determine if a relation is a function. So let's take a look at this relation. Negative 2, 5, 0, 4, 4, 2, 6, 1, 8, 0. It is graphed to the right. Okay, so we want to place a straight edge at the left of the graph to represent the vertical line. Okay, slowly move the straight edge to the right across the graph. So what you can also do is create a line, okay, and use a straight edge like a ruler, for example, and slowly move that ruler, that vertical line, across your line right there. Okay, now what do you notice? Every single time you move that vertical line across that line, it intersects that line at exactly 1 point. So for each value of x, this vertical line passes through no more than a point on the graph. What does that mean? So when I move it here, the intersection is there. That's only 1 point. When I move this line right over here, the intersection is between that line and the vertical line is that point. Okay, if I move that vertical line here, the intersection is also 1 point at this point. Okay, so for each value of x, there is a vertical line. This vertical line passes through no more than 1 point on the graph. This is true for every function. Okay, so that is now what we call the vertical line test. Okay, and let's take a look at example number 3. The graph on the left shows possible outcomes. Okay, when two-sided dice are tossed, the graph on the right shows those outcomes when the faces of the dice show a sum of 7 is either a relation or a function. Explain. Now, if you look at the the graph on the left, and we need to find out if it's a relation or not. The simplest way to do this is to use the vertical line test. You can use another test too, but a vertical line test would probably be the best one to use. So what we do is get that line. Let me choose, okay, that works. Then I'm going to put this line here. So if you notice, this is my vertical line. If I use the vertical line test and let it pass through this, okay, it will not pass the vertical line test. Why? Because as I move this vertical line across, okay, it will intersect this graph in more than one point. Okay, so as it intersects it more than one point, this is not considered to be a relation. At the same time, if you notice, for a value of x, there is more than one value of y. For example, 1, okay, is paired with 1, 2, 3, 4, 5, and 6. For 2, it is also paired with 1, 2, 3, 4, 5, and 6. Okay, so by the very definition, this is not a function. Okay, since it does not pass the vertical line test. Okay, at the same time, okay, for every value of x, there is more than one value of y that is paired with it. Okay, the one on the right, okay, however, is a function, because if I make a straight line here, if I create a straight line, then make that straight line. Okay, let's make that blue. Let's put 2 arrowheads there. Okay, so if you notice, if I make that straight line right here, then oopsie, that out of there. Okay, right there. That's my straight line. If I use my vertical line, every single time I move this vertical line across the graph, it only passes the line at exactly one point. So the right graph, okay, is considered to be a function. Hold on, there you go. The relation graph on the right is a function since any vertical line passes through no more than one point of the graph of the relation. Okay? And the secret word for this particular lesson would be saints. Secret word is saints. Okay? Thank you for watching.